Welcome to part 7 video. In part 6, we discussed the haloalkanes reactions and their mechanisms and what type of cleavage will be there and what type of reactions, elimination reactions will be taken place. Everything we discussed. In this video, we discuss the reactions of haloarenes but not haloalkanes. So, haloarenes, let us now have a few discussion important points. Generally, in haloarenes, nucleophilic substitutional reactions, whether they will take place or not, let us see. Generally, aryl halides are extremely less reactive. They are not that much reactive because many reasons are there. Let us discuss the reasons. The first one is resonance effect. Resonance effect means in haloarenes, the electron pairs on halogen atom are in conjugation of with the pi electrons in the benzene ring, and the following resonating structures will be taken place. That means chlorine is a nucleophile. So what will happen? The binding electrons will be supplied from the chlorine to the benzene ring. So that's why double bond will be taken place in the between the carbon atom and the chlorine atom. Wherever the reactions are taken place, their negative charge we will see. That means carbon-chlorine bond acquires a partial double bond character due to the resonance. As a result, the bond cleavage in haloarene is very difficult to remove the chlorine atom. It is very difficult than the haloalkanes. So that's why we can say that haloarenes, they are less reactive. They will show low reactivity towards the nucleophilic substitutional reactions. Whenever they give, we have to write down these resonance structures. While doing the resonance structures, check the negative charge. Wherever it is forming ortho, meta, ortho, para positions. Sorry, ortho and para positions, the negative charge will be taken place. So that's why the reactions will be taken place at ortho and para positions in a nucleophile. First reason is resonance effect. Second reason is difference in the hybridization state of between the carbon atom and the halogen atom. Already we know that in the haloalkanes, the carbon atom where the chlorine is or halogen is attached, that is the sp3 hybridization state. But in haloarenes, it is the sp2 hybridized state. So that is also one of the reason. So the sp2 hybridized state, if you take it, so in this one, a greater S character is more electronegative. S character is more electronegative, and P2, that is total 100% means S character is 33% and P character is 66%. S character is more electronegative and can hold the electron pair of CX bond more tightly than the sp3. Why? In the sp2, S character is 33%, but in sp3, the S character is 25% only. So that's why carbon can hold the halogen in the haloarenes with more electronegative and more tightly than in the sp3 hybridization. So that is also one of the important reason. That means hybridization state of carbon atom in the haloarenes. So this is the more character. So that's why carbon-chlorine bond length in haloalkanes is this much while halone is less. Since it is difficult to break the shorter bond, if it is there, it is very difficult to break the bond. So that's why haloarenes show less reactive than the haloalkanes towards the nucleophilic substitutional reactions. So this is the second reason. Next we will go for the third reason. The third reason is instability of the phenyl cation. In case of haloarenes, the phenyl cation formed as a result of self-ionization will not be stabilized by resonance. So that's why if there was no stabilization, then SN2 mechanism will be favorable, but SN1 mechanism is ruled out. This is also phenyl cation formation. Is also less stable. That is also one of the reason. Because of the possible repulsion, it is less likely for the electron-rich nucleophile to approach the electron-rich arenes. So electron rich arenes, so nucleophilic substitutional reactions will be very less. They will show the less character. So these are the important reasons. So that's why nucleophilic substitutional reactions in the haloarenes will be less comparing to the haloalkanes. So these are the reasons. One is the resonance stability. Second one is the character of the S and P hybridization character. And third one is the instability of the phenyl cations. So these are the three important reasons are there. Now let us see how the halogen atom is replacing some reactions they have given. First one, replacement by hydroxyl group. Chlorobenzene is converting into the phenol. So this is also conversions. So in the presence of sodium hydroxide and a protonated acid, it will give, so the chlorine atom will be removed and the phenol hydroxyl group is attached in the presence of sodium hydroxide. So this is the conversion of chlorobenzene to phenol. And again, in the presence of an electron withdrawing group, that is electronic withdrawing group, NO2 group, okay, then it will be taken place, NO2 group will be attached at the ortho position and the para positions, increases the reactivity of haloarenes. So this is ortho position, this is the para positions. So these are the important things are there. Suppose that is phenol and chlorobenzene and ortho para nitro chlorobenzene and ortho hydroxy or para nitro hydrophenol. So these are the important conversions, we should know it. Yes. Suppose if it is electronic withdrawing group is there, then what will happen? The reactions will be taken place at the ortho and para positions only, but no meta position reactions. So however, no effect of reactivity of haloarenes is observed by the presence of electronic withdrawing group at the meta position. If it is also electron withdrawing group is there, there was no reaction will be taken place at the meta position. Generally, the position will be taken place at ortho and para positions only. Out of these two, if para position is there, due to the symmetry, it is the standard or main product. So that point also we have to observe it. Now let us see some electrophilic substitutional reactions, whether they will be taken place or not, or whether they will be taken place very quickly or slowly. Let us see. So already we know that some electrophiles, that is benzene rings such as halogenation, that means nitration, sulfonation and Friedel-Crafts reactions. Let us see this one. Halogen atom, besides being slightly deactivating at ortho and para positions, therefore the substitutional reactions will be taken place at ortho position and at the para positions only. That means so if you know, by considering these resonance structures only, we can say that the attacking group will be attached at the ortho and para directing groups and at ortho and para positions only. Due to the resonance, the electron density, where it is increasing at ortho and para positions, it is more at ortho and para, but it is less at meta positions. So therefore, the halogen atom, because of its negative inductive effect, what is that? Negative inductive effect, has shown some tendency to withdraw the electrons from the ring. As a result, the ring gets somewhat deactivation. Okay, then electrophilic substitutional reactions will be taken place in the haloarenes, will occur very slowly, but in special conditions only the meta position reactions will be taken place. Otherwise, they do not take place. Only ortho and para positions only will be taken place. So that is the main. Where the deactivation is there at which positions? At ortho and para positions in the benzene ring. Due to the halogen negative character. That is the more important. So electrophilic substitutional reactions will be taken place under certain drastic conditions. Otherwise, they don't take place. So only ortho and para positions only will be taken place. No meta position. Let us see some reactions. Halogenation, that means addition of halogen. So chlorobenzene, haloarene, is treated with the chlorine in the presence of anhydrous ferric chloride. What it will give? It will give the two products, that is para and ortho. Out of these two, which will be the major product? Because when you observe it, this is having the symmetry and it can adjustable in the reactions very easily, so that this is the major product, this will be the minor product. And again in the nitration also, that is nitrous mixture, nitric acid and sulfuric acid mixture, if you take it means nitrate group will be added at the ortho position and at the para positions. Out of these two, which will be the major product? So since it is the symmetry, so major product is the 1-chloro-4-nitrobenzene. That is in the sulfonation, that is treatment of sulfuric acid. Then sulfate group is acid, 2-chlorobenzene sulfonic acid and 4-chlorobenzene sulfonic acid. Out of these two, which will be the major product? Since it is having the symmetry, so 4-chlorobenzene sulfonic acid is the major product. So these are the some reactions. Halogenation means addition of halogen. Nitration means addition of nitrous mixture. Sulfonation means treatment with the sulfuric acid. So these are the three important things we can use in the conversions also. So just we have to know it. Now Friedel-Crafts reactions. There are two types of Friedel-Crafts reactions. If it is alkyl halide, if you use it, that is called the Friedel-Crafts alkylation. If you use it acid chloride, then it is called the acylation. So alkylation and acylation, two reactions are there. Friedel-Crafts alkylation means alkyl halide. We have to use it in the presence of aluminum chloride. It will also gives, that means observe it, 1-chloro-2-methyl-benzene, 1-chloro-4-methyl-benzene. So in these two, which will be the major product? You know that it is having the symmetry, so 1-chloro-4-methyl-benzene is the major product. Similarly, acid chloride, CH3COOH, in the place of OH, if you read it, if they are having the chlorine, that is called the acid chloride. That acid chloride means acylation. Acylation, what they will give? They will give the 2-chloro-acetophenone. That is ketone will be formed, acetophenone, and 4-chloro-acetophenone. So these two, out of these two, which will be the major product? This is the major product. So this is also Friedel-Crafts alkylation and acylation. Just you remember, alkylation means alkyl halide we will use. Acylation means acid chloride we will use. Already we discussed that in haloarenes. So where the attacking species will be held. Already we know that at what positions? Ortho and para positions. Why? The reasons are given already. So here also they asked one question. Although chlorine is an electronic withdrawing group, yet it is ortho and para directing in the electrophilic aromatic substitutional reactions. Why? Because due to the resonance, okay, through the inductive effect and all these things we have to write down. Just you go through once this is the most important question. Already what we explained in the lesson, the same thing you have to write down here.